bones, dust in the air. Eyes to the ground, no one cares. Empty streets, whispers bite. Lost my way in the dead of night. Rock bottom, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no chains, no lie. Gonna find my way back to the top. Gonna find my way back to the top. Scrape knees, blood on my hands. Falling feels like sinking in sand. Echo scream, can't drown them out. Heartbeats loud, I'm done with doubt. Rock bottom, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no chains, no lie. Gonna find my way back to the top. The shadows laugh, but they don't own me. I've burned before, now I'm free. Fire in my veins, ashes in the wind. I lose, I learn, I begin again. Rock bottom hit it, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no change, no lock. Gonna find my way back to the top.
All right. Good morning, good afternoon, good evening, wherever you are. Welcome to the first live stream of The Architect in the new location in Florida. So I appreciate you guys joining, and I look forward to today's stream session here as we talk about what I've built here in the new house after my move on the 13th. Today is the 24th, and I think it's actually fitting. I left New York. It was pretty cold and snowy. And when I came here, I had relatives here, and they were like, well, you brought the weather with you, because actually it snowed twice in Florida since I've been here. In the Panhandle, I'm in southern Florida, but in the Panhandle, there was snow on the beach twice so far since in the last couple weeks since I've been here. So, but it's nice now. I can't complain. I want to say, I think it's 20 below zero at my old location. With the wind chill, I think it's below zero, freezing temperatures, even before the wind chill, right? So I don't envy, I don't want to sit here and look like I'm complaining, even though it was 60s for the most part. Today, I think it's in the 70s, a little bit muggy, but of course it's beautiful Florida. I'm 10 minutes from the ocean. It's the outside life, which I really like, and I know it doesn't look I got any sun, but the top of my head is a little burnt, so I got a hat on, and so I'm happy to be here, and happy that I get to do this again with you all and continue down the path with my live stream. So before I get into the content today, I want to just point out again that if you're watching on LinkedIn, I do see that it tends to be a higher quality stream on YouTube. I'm actually using a solution called Restream, which streams this in a delay, about, I want to say 60 seconds, about a minute, 30 seconds to a minute delay, depending on what platform. It's up to a minute, I believe, on LinkedIn. YouTube's around 30-second delay. But those are streamed to both platforms. So you can choose to watch them on LinkedIn. That's fine. But you can't interact with the chat, right? So there'll be no interaction there. It's only read only. But if you want to use the chat, you can certainly go over to the YouTube channel. That's linked here below. You can see that here. That's the live stream URL for YouTube. And within YouTube, you can actually join the chat, make comments, etc. So whatever you want to do, it's up to you. But I want to give optionality to my audience. So again, thank you for joining. Today, we're really going to focus on what I've built here in Florida to continue my technical education journey and to give me the services I need day to day, right? Either for my job or for self-hosting services, or for basic file storage, networking, etc. And what I did was I taken the lab that I've shown you up in the New York location that I have in my basement home up there, which is still there, by the way. And continuing to use that for more broader enterprise demonstrations and content around Nutanix. This right here is more about up leveling my education and giving me services to the home, and I still leverage that enterprise capability at home. Again, this is like going to the extreme for home labs, right? You don't have to do this. You don't have to invest all this money, time, and effort, depending on what you're trying to accomplish. I always go back to the use case as an engineer. I always go back to see exactly what you're trying to accomplish. That has to be defined first, and then determine your budget, and then from there you go from there, right? And that's still under consideration even in the home lab. So I mean, this is how you do things in the enterprise, and how you kind of work backwards from the use case. What are you trying to achieve, or what are you trying to solve, right? And work backwards from that. And it's just the same applies. Like, that doesn't go away. That thought process and mentality does not go away, right? So don't think that this is a brag. I don't like to show off. Oh, look what I have. That's not what it's for. It's to give you ideas on what it is you're trying to accomplish, and maybe you take pieces of those ideas, or maybe you mirror what I've done. It's depends, right? So that's kind of the goal here, and the goal is to kind of, for me, my use cases, like I said, are up leveling my skill sets always as a technical person, right? In the role I'm in, or even being a technical person in general. And as we move down this more AI generation, right? And I know you're probably sick and tired of hearing it, but get used to it. AI is here. It's not going anywhere. It's exploding everywhere. Okay. I'm not going to talk about bubbles and all these other things, right? Regardless if there's a bubble or not, it's not going away, right? What happened with the web, right? What happened with the .com era? The bubble burst in the .com era, and look at where the web is today. It didn't go anywhere, right? It actually exploded, right? So AI is exponentially innovating. Excuse me, let me rephrase that. Innovating exponentially faster than any technology we've had in the past. Okay, and the common life cycle, this 10-year adoption cycle, whatever you want to call it, right? That we see going from early stages into mass, acceptance, right? Mass deployment. It's moving much faster, I think, than anybody ever expected, even in the enterprise. And the enterprise doesn't move fast, as you know, right? So, going back, right? Again, these labs are built for me. This environment's built for my education, my demonstrations for work, right? And my services that I require at home. Okay, so just to get into it really quick, I'm going to go to share my screen, and we're going to focus on, and let me just lower this here into my other screen. We're going to really focus on what we talked about in the last episode and in my blog post around my proposed rack layout. And so you see the screen here. To the left was my proposed rack layout, and then to the right, this is the actual layout. Okay. And what I've done is I've basically miniaturized the solution into, and you've probably seen these on YouTube, but these mini racks are becoming very, very popular because of space, power, cooling, right, and budget. And the fact that you can get plenty of power, or a good amount of power in such a small footprint today, right? You don't need these rack scale solutions, right? Large rack scale solutions I'm talking about, to give you a significant amount of performance and capacity anymore. It's the idea of Moore's law, right? Moore's law is packing more into smaller footprint, and that's what we're seeing today. You also probably see a device over to the right hand side in the rack, second from the bottom, that looks like an NVIDIA DGX Spark, and that's what it is. And I'll talk about the reason why I purchased it and what I did to afford that, because it is an expensive piece of kit. It's very expensive, as a matter of fact. And I didn't buy it new, I bought it used, so I saved there. But I also sold my RTX 5090 in my workstation and other things to accommodate to offset the cost of that. I don't need an RTX 5090, right? As a matter of fact, with NVIDIA's DLSS, once again, AI, right? You can get away with a 5070 or 5070 Ti and still get phenomenal performance when it comes to gaming through DLSS and FrameGen. And NVIDIA just released DLSS 4.5, which gives you significant advancements. Of course, we're waiting for more games to adopt that. But again, this whole idea that you need to have an RTX 5090, and as a matter of fact, if you look at NVIDIA's direction and how they're looking at the consumer, that's really what's happening. I mean, look at AMD. AMD really didn't release a high-end card in this generation, right? The 9070 XT is their best card. The 9070 XT compares to the RTX 5070 Ti in the NVIDIA's line. And they're using upscaling with FSR, right? So I think the days of, these massive GPUs for consumer, right, gaming experience, I think those days are pretty much over. I think you're starting to see AI technology come into play and those things. And I see a lot of complaining, and I know I'm going off on a tangent, but I just want to talk about this really quick. The hardware enthusiast YouTube channels are in complete panic mode. And the reason why that is because they've relied on continuous releases from these hardware vendors to create content and to push content out. Okay? That's the reason why they are in panic. And what I'll tell you is that they should, instead of fighting against DLSS, instead of fighting against these technologies that allow you to get phenomenal performance in a lower cost envelope, right? Instead of focusing on the advantages of those things and the technology behind that, they focused on an anti-NVIDIA campaign, okay, which I think is a mistake, to be honest with you, or an anti-AMD campaign, because CES just happened, right? CES is post New Year's at the Consumer Electronics Show. You had AMD, Intel, NVIDIA, all there talking about AI, right? And not really talking about so much the consumer side of gaming performance and things like that. The focus was really on AI. And so that's really what it's going to be going forward. And so this idea that we're going to fight against it or go against the grain, not going to happen, right? So I know I went off on a tangent there, but I just wanted to mention that because there's some tech tubers I watch, and the anti-NVIDIA, anti-AMD campaign is kind of getting old. Now, the comments around costs, that's a different conversation. I'm talking about pure technology, right? And I think there definitely should be a conversation around how AMD and NVIDIA and those folks are leaning towards costs, right, when it comes to these lower end GPUs, right? And the fact that they should be churning out more of those instead of holding back on manufacturing for those because of AI. That's a different conversation, and there's certainly challenges there and things to be talked about there. But the technology side of it, there shouldn't be there should be no anti FSR, anti DLSS, anti frame gen. That should just go away. You should be embracing this technology. It's getting better and better and better. Okay. I want to go back to my original proposed rack layout. It's a little bit different. Matter of fact, some of the things aren't even configured yet, like the LCD up top. So before I even start, this is the rack. Over to the left-hand side, you see the racks here. I went and got the Rackmate I think the TT Black version. It was only $60, and let me tell you, this came with everything. The screws, the directions were simple. The hardware screwdrivers, they gave you two, a hex screwdriver and a Phillips head screwdriver with it. Nice, decent ones. And the layout of the box and how everything was laid out was put it this way, the unboxing experience was phenomenal. For $60 rack, it was phenomenal. And it's solid, right? It's not cheap. Doesn't feel cheap, doesn't feel like junk. It's extremely solid. And it comes with panels. It came with the tray. Matter of fact, I'm using the tray right now for the DGX until I get I may just keep the tray for the DGX because the DGX does get hot and I want airflow to kind of be going around it internal, right in the front. This is a mesh front panel in the DGX Spark to the back. And so, you know, I may keep it in a tray just for the airflow aspect of it. But what I've done is, again, I've got the DeskPi Rack-made TT along with this 6.9-inch, 91-inch touchscreen display. That is not configured yet. That's going to be for a live active monitor for a lot of these systems here. And the reason why it's not connected is because I'm using Jet KVMs, okay? So over to the left, which was not part of the proposed layout, is a Proxmox server, an ITX Proxmox server. I basically repurposed that. Remember the DGX do-it-yourself Spark system that I built? I repurposed that for Proxmox because I needed a little virtualization platform here, down here for specific VMs. I don't like to run, even though I could run some VMs on the NAS and Docker containers, I don't really like to do that. I have the hardware. I'm running Proxmox. I actually inserted or implemented or installed, replaced the RTX 4000S FF8, which was also sold. Okay, so that with a 5090, was a good chunk of change. And I installed and replaced that with a Synology 10 gig PCIe by 16. It's a 10 gig NIC with two NVMe M.2 storage slots. All right, so that allowed me to add additional M.2. So with the Miniswarm AR900i, that has four M.2 slots already, and then I could add two additional. So I have basically 6 total NVMe M.2 drives in this Proxmox server. And I have 10 gig, right? This Synology now gave me 10 gig for that server. Just from top to bottom, really quick, going back to the LCD. The LCD is not connected, and here's the reason why. I want to go back to the Jet KVMs. The Jet KVMs, one is connected to the Proxmox server and uses the HDMI port on the Proxmox. The original plan was I was going to basically pass through the Intel NIC to a VM and then connect the LCD to that and then run my monitoring suite on that virtual machine. That was the idea. I'm not going to do that. I'm going to do this a little bit differently. So I basically ordered a cheap kit of Raspberry Pi, a Pi 5 basically with 8 gigs of RAM, 64 gig SD card. Okay, it's a little kit. I want to say it cost me about $150. That's going to be here tomorrow, and I'm going to be connecting that kit directly to the LCD here, and then I'm going to still use. I haven't decided. More than likely, I'll be using Kubernetes running on Proxmox VMs. Probably more than likely either Ubuntu or even lightweight Talos Linux to actually have a lightweight operating system for VMs for the nodes, for the Kubernetes nodes, right? And in that, I may run, more than likely will run a PGL stack, right? Prometheus, Grafana, Loki stack. That's going to ingest all the logs. It's going to scrape all of the metrics, right? And then we'll use Grafana to create the dashboards for visualizations, right? So that's the LCD. That's kind of what that's going to turn into. That's going to be starting tomorrow when I connect the. I have to configure the Pi, and then connect that to this. That's why it's not on right now. The second slot is my core gateway. Okay, this is basically the cloud gateway fiber from Unify. And I have to say, I have a really beefy Dream Machine SE in my New York data center location. That's for the enterprise gear and the network there. That's a pretty beefy device. This thing is pretty phenomenal for how the size of it and the performance that you get of it. So first of all, this device has 4 2.5 gig ports, right? From a switch perspective. Okay. One of them is PoE++. As a matter of fact, that's what's running this access point, which we'll talk about in a few minutes. Okay. Then it has 3 10 gig ports, one RJ45 port and 2 SFP plus ports. And you can see here to the right, I have all the way to the right in that device, I have a SFP plus to RJ45 adapter plugged into that, so I can actually do my trunk between the cloud fiber, the cloud gateway fiber, and my Flex XG 10 gig switch. All right, so I don't want to get too far ahead though. But this is the device. Within this device is also an M.2 sled. Okay, so the sled doesn't come with it. You have to actually buy the sled. Okay, and then you can install an M.2 on the sled, slide it inside, and you can use that for NVR storage for your NVR, right, for your cameras. And that's what I'm doing. Okay, I didn't go crazy here for cameras, and I went all wireless here. Okay, I'm going to tell you why I went wireless, because a lot of people don't like wireless from cameras perspective, because typically it's not reliable. Okay, but I'm going to talk about the wireless here in a minute. The next device down here is I have a pass-through uh, patch. Okay, that has pass-through in it. It's very small. It's got 12 ports. It does Cat 6, right? It's Cat 6 capable. And right now I'm using 1, 2, 3, 4, 5, 6, 7, 8 ports out of the 12. All right, when it comes to the connectivity. So really quick, from a color scheme perspective, it's not the same on the planned. And the reason why is because I ran out. As a matter of fact, I do have to get one more white connection here. But basically, anything that requires unified to unified connection. So a trunk between the Cloud Gateway Fiber and the Flex XG 10 gig switch, the connection right between the access point, right, and the Cloud Fiber, right, which is providing the PoE plus plus for that access point, and the connection from the UPS, which is a unified UPS, which is pretty slick little UPS, and connected to the 1 gig port on the Flex XG. This should be white cable. That's what I'm talking about, right? So this cable down here, this cable to the left, right, is black going up to the patch. That should be white. I'm waiting for a cable to replace that. So everything white is basically unified to unified connectivity. Okay. The black up the upper left, right, those 2 ports are for my jet KVMs, right? So that's my out of band management network. Okay, so there's a network for out of band. That network can't connect to anything. I can connect to it, of course, from my workstation to that, and I will be able to connect to it through my um, uh, WireGuard, right? My VPN connection. So if I'm in a hotel or whatever, I could do that. As a matter of fact, one of the devices I'm actually going to purchase for travel is the new Unify Gateway travel gateway. Okay, because that what it'll do is when I plug in or when I connect and bridge the wireless connection in my hotel room, right, or in a customer site, I'm now on my network. That's what it feels like, right? So I don't have to create all of this complex VPN connectivity. All right. So let's go back to Blue. So Blue is basically the internet, right? So Blue is the internet coming in. I had the cable modem that's behind this. It plugs into port 12 on the back, and then this plugs from port 12 from the patch into the WAN port, right? Which I've defined that RJ45 10 gig port. That is the WAN port. Okay. And then these 2 10 gig ports are now changed persona to internal LAN ports. So they're basically switch ports. Okay. So you see what the black is. You know what that is, out of band. White is unify to unify. Blue is internet. And let's talk about the yellow, red, and green here. So yellow is the connectivity from my NAS. Okay, that's the NAS connection into the Flex 10G. The red connectivity, okay, is the Proxmox server. So that's basically the Proxmox server going into the Flex 10 XG. And then the green is the NVIDIA DGX Spark. Okay, and that's the 10 gig port on back of the DGX Spark. I'm not using the Connect X7 ports because I don't have another DGX Spark, and I probably will not have one because I'm not going to buy and spend another, all that money on another DGX Spark to have a cluster. I don't really need it, to be honest with you. So a cluster, I mean. So I'm just using the 10 gig port for that. And so everything basically is connected 10 gig with the exception of the Unify UPS, the out of band management, which is basically fast Ethernet, right? It's basically, or excuse me, not fast Ethernet, it's 1 gig. Okay. Even though they're 2.5 gig ports, they're multi personality, right? And then the Unify, the access point, which I'll talk about in a minute, that's 2.5 gig. Even though it's using, it's using the 2.5 gig port, and that is 2.5 gig going to the Unify. And then this UPS only does 1 gig into the 1 gig port. All right. So that leaves me basically 2 ports, one 2.5 gig port on the cloud gateway fiber and one 10 gig port. And I do have another SFP plus to RJ45 adapter. If I don't use SFP, and I need an Ethernet port, I basically have two additional, one 2.5 or 1 gig and one 10 gig that I could use on here. So more ports than I thought I'd use. But to be honest, I don't see myself needing any additional ports. My desk right now is to the left of this. And I could connect into the 10 gig port here if I wanted for my desktop. I am using wireless right now. And you're probably like, why are you doing that? You're right there. Because the plan is to move my desk. My floor is being done in my bedroom. So my plan is to move my desk out of here because this is a den and this will house visitors, right? When they come in here, we have a couch here that expands to a bed. And so people will have to sleep in here, and obviously I have to work. And so this desk that I have, and I haven't really talked about my desk. This is probably one of the best desk setups I've had. It's small. It's actually way smaller than the one I have at home. And I thought it was going to be too small, but it's actually working out great. This is going in my bedroom. Okay. And so I will still need to use wireless because there isn't any wired connections, right, into any of the rooms. And I'm using wireless. Okay. So let's go back down to the rack again. So I talked about the Flex XG. That's basically a four ports 10 gig and 1 port 1 gig switch. Okay. So there's a 1 gig connection to the left, and then there's 4 10 gig ports on that. Those are all full. And by the way, all of these things have mounts, right, for the rack that were 3D printed. So what I did was I don't have a 3D printer yet, so I went on Etsy and I did a search, and I was able to find 3D printers support for pretty much everything here. Okay, and so that's 3D printed the mount for the cloud network fiber. Then you have the patch. Then there's a 3D printed mount for the Flex XG, and then there's a 3D print that I found. There's a guy on Etsy that does. You can do multiple, up to 4 jet KVMs and a single U, which is nice. I only have 2 jet KVMs, so I got a 2U, basically a 2-port 3D print panel for the jet KVMs for out of band management, and that connects to my Proxmox server, and it connects to my Ugreen NAS. Next is a shelf that comes with the rack, and I basically, you know, the reasons why I put the DGX Spark there for cooling. And then there's a 3D print, and this is actually pretty big. It actually takes up two U, right? Basically, if you think about U's in this mini rack, and that fits my Ugreen NAS, slides right in the back there. Okay, so that's pretty much the rack. Like I said, it's pretty awesome. I love it. And like I said, the quality was very good. The directions were very good. And people swear by these. You can see these online. A lot of tech tubers who focus on home labbing, right? Like Techno Tim, Jeff Gerling, all these guys, right? They have done a lot of content on these. So I won't do any content on this. If you want to learn more about that, you can certainly go over to those YouTube channels and get more in-depth detail on that. So I want to talk about the wireless because you're probably saying that wireless looks pretty different than most wireless that we see. It's not the your typical access point, right? Round, etc. So what I did was the new home in Florida is 1,400 square feet. right? And then I have an outdoor lanai in the back, and then the driveway, the garage. Okay. I wanted to make sure that I had an access point that could reach that, right? So what I did was, let's just go to the Unify store here. Sorry. So we'll go to the store and we'll go to Wi-Fi and we'll scroll down here. And what I did was I purchased the outdoor. Did I skip over it? Yes. I purchased basically the U7 Pro outdoor. Okay. And one of the reasons I did that, the primary reason, right, is the range. Okay. So basically what the outdoor gives you, right, is um, these omnidirectional antennas that you see up here, which really provides a much more capable range. Okay. And I know you're probably thinking, well, Mike, that shouldn't be installed like that. Believe me, just leaving it there like that is fine. It covers everything I need to cover at phenomenal speeds. And even though there's only one device in the house that supports Wi-Fi 7, and that's my wife's phone, I'm getting a new phone here shortly. I'm due for one. I've actually had this so long as I've had an iPhone. Believe it or not, I've had this iPhone for 3.5 years, and it still works good. It's just scratched up, and I need a new one. But my phone will support Wi-Fi 7, and then when my daughters come, they're going to have iPhones that have Wi-Fi 7. And as we get new devices, right? My laptop, as an example, that supports Wi-Fi 7. Um, as new devices come online, we'll have that Wi-Fi 7 support. Okay. I'm not using Wi-Fi for anything other than PCs and cameras. Okay. And so for cameras, what I've done is um, I purchased, um, actually went cheap down here. I have much broader cameras at home. I have um, pan tilt zoom, right, at home. But I went with the instant cameras, the wireless instants. Let me see here where they're at. I'm skipping over. Huh. Yeah, I don't know where the instant. Maybe I skipped them over. But I went basically with the G6 wireless cameras, and they work good. They're not 4K, they're 2K, but they're fine. That's pretty much all I need down here. Um, and and they're easy to mount. And I bought these 3D printed mounts for the one in the kitchen that faces the back one, and then I have to install one in the front. I'm still waiting for a drill, so I have to go buy a drill. I'm not sure where those cameras are. I don't know if they're out of stock or what, but yeah, the cameras basically they're fairly small. They look like I know I'm probably killing your eyes here going through this. They look like these, right? The instant, right? Basically, I got the G6 instant cameras, and they do have a mount on the back that you can put on. Now they are USB-C powered, so USB-C to outlet, right? Or if you have a USB-C to USB-C power capability, you can do that, and they're wireless. Okay, so I think it's they're wireless, but they still require the power, right? Of course. And so what I've done is I had a contractor put an outlet on the front side so I can plug it in. And then the one I have here is in my kitchen inside, and then there's one that's going on the back side in the lanai, and I still have to get a contractor to come in and put a power outlet there. Okay, so I'll have basically 3 cameras covering the house. And that's all I'll need. I will be getting sensors though, probably because this is Florida, and I live near the coast, and so I do want to get some environmental sensors. So you'll start seeing me as soon as the SuperLink gateway comes in stock, right? I want to make sure I have some sensors, entry sensor, a motion sensor in the garage, and environmental sensors where the HVAC is, and to make sure that there's no leakage or I get alerted on entry um, water, environmental issues, right? Humidity, things like that, in case something happens. Okay. So that's pretty much the hardware, right, for the home lab. Let me just go into what we have here from a capability perspective. So, you know, Unified just released this fabric, okay, in the site manager. I'm not going to get into that. We'll talk about that in another time. But basically, what Fabric is it basically is a holistic view of your entire network, where you can push down policies, you can give automation, you can set up API integration. There's identity access management, right? So when you onboard an employee, that employee at a location maybe has door access, has access to log in, has access to certain networks and the Wi-Fi. All those things you can create one policy around. So it's pretty awesome what Ubiquity is doing when it comes to um, more commercial stuff. I'm not saying enterprise grade yet. I think they have a long way to go there, but the idea of what they're building can definitely be pushed into the enterprise as soon as they get more enterprise robustness in their products, right? And they do have some enterprise grade stuff, but I don't see that. Everybody's where I go, I see Arista, Cisco, right, Dell, but mostly, now Mellanox or NVIDIA, right, when it comes to AI stuff, and people are buying Spectrum X and Spectrum X networking, right, whether it's Ethernet or InfiniBand, depending on what they're doing with AI as an example. But we're seeing NVIDIA actually grow in the networking space as well. So, but I don't see Ubiquity so much in the enterprise space, right? And that's really what I focus on is enterprise. So quickly, I'm in the Cloud Gateway Fiber, but you can see here I have my Dream Machine that's home, my router, my Dream router that's the camp, and then Vantage Point is my combined sites for security. Okay, and this is where all my cameras are. Okay. You see here I have my Jet KVMs. I'm actually installing Proxmox on this machine. I'm trying to figure out there's something going on with it. This one's connected to my Ugreen NAS. This is my one connected to Proxmox, not coming up. Not sure why. I have to figure that out. But essentially, these are my out-of-band management connections to those two devices. Here's my Vault. All right, I call this Vault, but this is my Ugreen NAS. It is running Ugreen OS. I did talk about whether I'm going to keep Ugreen OS or not, because it's Chinese affiliated, and I got to go back, right? I just don't trust anything from China when it comes to operating systems, especially when it comes to data. Um, I know it's hard to say because most electronics that we have, or a lot of electronics we have in the home, are run by Chinese software, right? And I just try to limit that, try to minimize that. So I may be putting TrueNAS on this. I'm not sure yet, but what is it? So basically, it's M.2 NAS. Let me log in here. I timed out. And it's basically 4 to M.2 drives, right? It's a pretty powerful NAS. So if I give an overview in the control panel, hardware and power, it's not here. I haven't really messed with this so much, so I'm not that familiar with it yet. Let me go in here. Here we go. So basically, it's a NAS that very, very tiny, right? Footprint like a mini PC, and that's what it is really. And it has 4 M.2 slots, 10 gig port. It does have Thunderbolt. It does have HDMI, etc. But the CPU is basically I think it's a 10 core CPU, Intel variant, a T variant. I think it's a 12600 or 12700, 12600 maybe T or 12400 T. It's 10 cores. And then it came with 16 gigs of RAM. I upgraded that before RAM went crazy, to 96, so 248 gig sticks of SO-DIMM memory. And you can see the networking here, right? The disks, right? Volumes, etc. So it's a pretty great, actually, gives you pretty great visibility and management, though. I got to give it that from an OS perspective. And then, of course, you have your apps, right? So there's apps that you can download and use. I try not to overload my NAS with apps. I know a lot of people do that. Not overload, but they use their NAS for a lot more than just storage. But I try not to. If anything, if I keep UNAS, or excuse me, the UNAS OS and not go to TrueNAS, more than likely I'll be running a few Docker containers, but nothing more than that. I won't be running virtual environments. That's what I have Proxmox for. And even though this does virtualization, et cetera, but I can do all different things on here, right? You have virtual machines, you have media and entertainment. I think you can do Jellyfin, right? If you want to do like streaming, you get the NVIDIA toolkit, right, to do LLMs. But obviously, I don't have NVIDIA installed GPU on here, so I'm not sure why that would be part of this. And a whole bunch of other stuff like cloud drives, etc. Right? But if you wanted to install apps, right, via Docker, right, you have image access to the image database. You can upload an image, right, Docker container image. But basically, you have access to thousands and thousands of container images for containerization, right? And I don't have anything running on this now. I did use this at home for Steam Cache because there was 5 PCs at one point, 5, 6 PCs in the house. My daughter had PC. She had one for her friends. My PC, my wife's, my other daughter's PC. So, and then her fiance, and so Steam Cache worked really well on this. And I just basically had 2 Docker images running Steam Cache, and the ability to actually load a game. And these games are so large, right? And using Steam Cache, that's what I pretty much ran in this, and it actually ran flawlessly. I actually just deleted it because I only have one system down here, so I don't really need Steam Cache here. Right. Okay, I want to talk about the DGX because I think this is probably the most exciting thing in the lab. Let me just refresh to see if it installed. It didn't install. Okay. So basically, what you do with DGX is you install um, um, NVIDIA Sync. Okay, so what Sync does is it allows you to set up your DGX, you configure it, right? And then you have access to do specific things, right? So, for example, I can start Jupyter Labs and use Jupyter Notebooks if I want. This is a DGX dashboard, so I get summary of system memory and utilization, right? I can look for updates. I can edit the host name. I can manage telemetry data, right? All of those things. I can go to docs, so there's links to for documentation. There's links to the forums, and by the way, the forums are very active for Spark, and people are doing a lot of really, really cool and unique things that you know you can't think of everything. So people have an imagination, and they're thinking about, well, what could I really use this for, right? And I think it's pretty awesome that you can use it for all these different things, and people are coming up with ideas. And so I'm looking at some of those ideas, and I think they're pretty phenomenal, actually, what I've seen so far. And then you have resources. So there is in buildnvidia.com, and buildnvidia.com is really a great site. Even if you don't have a Spark, right, or you have NVIDIA GPUs and you're doing NVIDIA inference, or you're looking at things to test out, there are models and blueprints, but the /Spark is directly for the Spark. I have to tell you that the Spark is a combination of ARM and Blackwell architecture, right? So it's a Grace Blackwell platform, just like a real DGX, right? And I know people are talking about the next gen, right? Grace Rubin, or excuse me, Vera Rubin. And now you have Vera, which is the new ARM architecture, right? With Rubin, the new GPU architecture from NVIDIA. That's what's next. But right now, this is Grace Blackwell. And so it's ARM and Blackwell combined. And so you can't just go and download, I'm going to go to a model and I'm going to download this model, because a lot of models are built for x86. They're not built for ARM, right? And so you have to make sure that you're using, ARM-based models. So, for example, in the Spark that I have here, I have a demo for a Llama model that's built just for Spark. Now, it is DGX. And so one of the things I want to point out quickly And I don't want to go over 12 today because I know it's a Saturday. I hate going over 12 and going over an hour. So I'm going to try to summarize this up, and then we're going to do a session just on DGX Spark, either next week or the week after. But it's still DGX, and so you still get the NVIDIA software stack, the DGX OS, right? And so you're getting all the NVIDIA tooling that you would normally get in a real DGX system that is Grace Blackwell, as an example, right? And so you have Ubuntu, basically, operating system. And, I haven't installed Kubernetes on here yet. I will be doing that. So I'm just using basic Docker. But the reality is you have to do a lot to get things working. Not to run a model and inference, right? But I'm talking about if you want to do something, and these aren't built for production, but if you did, just like a DGX, there is a lot of work that you have to put in to get it production ready. Okay. And what NVIDIA is great at, okay, is the silicon is phenomenal. Okay. The frameworks are phenomenal and the tooling is phenomenal. Okay. The problem is NVIDIA doesn't make it simple. Okay. There is no simplified solution that gets you from infrastructure to hosting endpoints. Okay. So you have to build that yourself. And so one of the things you can do with Spark really quick is when you go to the NVIDIA Sync application, you can launch VS Code and it'll connect within VS Code to your Spark device. And so this is what I'm in my Spark device now. Okay, you can see here my Sheehy Spark. This is my Spark host name. Okay. Now, what's not in here? Well, pretty much anything to run inference. I mean, all the frameworks are there. The NVIDIA Container Toolkit, Python, right? All these things that we manually installed on the do-it-yourself DGX Spark in the previous live streams that I did and the demos that I did, right? Around video search and summarization, comfy UI, right? There is walkthroughs of that, but it's all manual, right? It's a very manual process. The same thing applies to DGX, okay? And the real DGX. Now, in the real DGX, you'll implement Kubernetes, but then you have to build the whole Kubernetes layer, the observability stack, the gateway, the ingress, the manageability of all those things, the orchestration, all that has to be built. It's NVIDIA doesn't do that for you because they go in and say you use what Kubernetes you want to use. But if you do that, understand that you have to build all of that, right? And so what I've done is I basically created a environment where I can simply deploy search for NIMs that are supported on DGX Spark for ARM, deploy models, right, and stop those models and actually test, right? So basically, I have scripts to actually search for models for NIMs, right, an NGC. I have a deployment script that actually deploys the model and then validates it's working and tests, basically does basic tests against it. And then I have a stop, right, script that actually stops the container, deletes, right, cleans up basically. And then I have a whole test environment where I have a simple Python test application for chat, for interactive chats. I can test endpoints for quick API access, right? And so I have the ability, based on what I've built in my scripts, to do this quickly instead of manually typing out YAML configuration. Okay. So, just really quick, I'm going to go into search and run the search, right? And it's going to go through and it's going to list some of the models. Let me just make this bigger so you can see. Looking for, Spark specific models. So here's one, Llama 318B instruct DGX Spark. So I'm going to show you how to deploy this. Here's a Nemotron Nano, right, for Spark. Here's a Quen 32 DGX for Spark, right? So I can go through and I can deploy these, right? But I have to manually do that. I have to go basically into buildnvidia.com/Spark, go to the model, and then I have to go do a Docker run command, with all of these configurations for how much memory is allocated to the GPU, etc. And as a matter of fact, that doesn't even have the endpoint. There's an endpoint, but there's no API key. So it's completely in the open, right? And so this goes back to the overarching challenges with NVIDIA. Don't get me wrong, I love NVIDIA. They're one of our great partners. So I'm certainly not talking bad about NVIDIA, but there's definitely a challenge from a simplicity perspective. And that's where Nutanix comes in. Nutanix layered on top of what NVIDIA provides from a silicon, accelerated compute, frameworks, tooling, right? Nutanix takes that and gets you to consumption in 3 clicks. Okay, that's what I love about the combination, right? The partnered solution of Nutanix and NVIDIA. But in this case, I'm just showing you what I'm doing with DGX Spark vanilla, right? With its current OS. And so let's do this, right? So it does check your, right, what your system architecture is, the script does, etc. And if you want these scripts, I can certainly share them with you. Just let me know. And then so now if I want to deploy a model, so let's go. And so you'd have to actually update the deployment script, right? So if I do a VI deploy, right, in this one, I'm installing, right, the Llama 3.1 8B Instruct DGX Spark model, okay? And it's creating an endpoint. And by the way, I create the API key. I've already created it, okay? So I'm using an API key that I've already created. And so it forces you to use the API key, even though that's not native to what DGX provides and what NVIDIA provides. I built that myself, okay? And then it goes through testing, right? So it downloads it, rolls it out, right? And then does some testing against that to validate. All right, so let's get out of this. And let's go through a deploy. Sorry. Right? And now it's going through, and this is not the first run. So I'm not actually downloading the container. It's just bringing up the container, right? And if I actually wanted to open a new terminal, right, I could go in here and say Docker PS, and you can see here the container's being set up. Okay. It's not ready though. It's not ready for endpoint access. So that's going to take a little bit. But because I've already downloaded this, that's why it's actually running so fast. If it wasn't downloaded already, right, it would have to go through that download for the model, right? And depending on the model size, that could take a little bit longer. Obviously, the larger the size, the longer it is, and of course, depending on your bandwidth, right? So let me go back to here, and you can see here it's waiting for the NIM to be ready, right? So, essentially, instead of me having to do this, and I'll show you what it kind of looks like, right? Oh, I'm gonna here. This is NIM on Spark, right? This is the directions. Make sure you have the requirements, which you do for basically for excuse me, for the DGX Spark. You will have these requirements already. It basically wants you to make sure your Docker user is set up, right? Export your NGC key, right? Your NGC access, and then export all of these variables, right? Create your NIM cache, do all that. Well, I don't want to do that and then run the Docker run command with all these variables, right? I don't want to do that every time. I just want to go in and just change the model and maybe configure the SH, the shared memory size, right? That's it. That's all I wanted. And then that's all pretty much all I want to do. And so if I have a script to do that and make it repeatable, that makes it repeatable for me. And so it actually is a much better outcome than going through this every time, right? And then going through the curl I'm going to test it now and run a curl command against the endpoint, right? My script does that for me and says it's ready, right? I don't have to worry about that, right? And not only that, I actually have an endpoint API key, right, that I have actually created, which this doesn't have. There's no key in here, right? There's an NGC key to get to download the model, but when I provide the model endpoint, there's no API key against it, and anybody who has access to that machine can access it. It's very dangerous, right? And so the point I'm making is very, very simple. You are building the AI platform when it comes to NVIDIA. Okay? You're building it. You're manually building it. And I know this is not a complete demo because a complete demo would be not just the models and the endpoints, right? It would also be the Kubernetes layer. Okay. And I'm going to show some of that a little bit later. And I've done this in the past. I've shown this where Nutanix comes in from a Kubernetes layer perspective and the AI inference layer perspective, where we're not replacing NVIDIA, right? That's not our goal. Our goal is to be in lockstep from a partnered solution with NVIDIA to say, you know what, NVIDIA, you have great silicon, great frameworks, great tools. We love all those things. Our customers love all those things. Now let's make it easy for the customer to consume. That's the whole point. And operate, right? That's really the whole point. Okay. So let me go back and see if this is running now. Yep. So it's running, right? Here's the API key. It's healthy, right? And now I can go in and test it. So I do have the environment to test. So I go in and I go back and I go into test client, right? I can do the chat client PY, right? So if I want to run the chat, now I have a Python chat interface. Tell me about NVIDIA briefly. All right. And so now this is going against the model running on DGX Spark. And you're like, okay, well, what's my utilization and all those things? It goes back to what I was showing you before, right? You have the ability to look at the dashboard. This gives you a little bit of visibility, not a ton, right? But you can see here the memory I'm using, right? GPU utilization was up, right? Because it already answered. So if I go back, it probably already answered the question. It did, right? So it gave you an overview. So I know you're saying, well, that's all you're doing is inference. That's not what it's built for. It's built for other things. I know. I'm just getting started with it. And I don't want to play around with some of the blueprints that they had, but I also want to, at some point, install Kubernetes on this. And I can't really talk really a lot about it, but I'll just say this. Nutanix will be able to run NKP, the Kubernetes platform, will be able to support this at some point in the future. And I can't tell you when, but it's coming, meaning that NKP will support ARM as well. Right. So now I have the ability to say, okay, I'm going to create a cluster and add a worker node pool with the DGX Spark that is running, the NKP that's supported through the NKP platform using Kubernetes based, ARM based support for Kubernetes, right? And support the GB10 through the NVIDIA GPU operator. So that'll give me all the kind of that enterprise capability without me having to go in and say, oh, I got to build all that. I got to build my PGL stack, man, my Prometheus Grafana Loki stack manually. I have to then set up the scrapes for my DLCGM operator, right? I have to create the dashboards. I don't want to do all that, right? We already have that built in to NKP, and so the goal is to make it easy. Again, NVIDIA is great. They bring the supplies, right? Think of them like as the supply company. You're building a house or whatever you're building. They bring phenomenal supplies, the scaffolding, right? All of those things. And then Nutanix builds the AI house, the AI factory, right? It brings it all together from a consumption perspective. And so now you have two companies combined that get you to a much more consumer friendly experience, right? And we're going to show you that here in the coming weeks. I'm going to focus more on DGX Spark and some of the things I'm doing here in the next session. I hope you have a great Saturday and the rest of your weekend and a very productive week ahead. And I look forward to talking to you soon. Have a good one.